All right, so real quick video just to make sure you're comfortable with another type of problem. I found this going through Delta Math and I really like the way it's asked. So this is called evaluating integral functions presented graphically. So here's what's happening with this. So they're going to give you a picture. So they're not going to force you actually to integrate by hand. And then they're going to give you this equation that involves a definite integral and ask you to evaluate. So if you look at the directions here, it will say that g of x is equal to this integral, the integral from -6 to x of f of t. Now you might be wondering, why are there t's there? It is not legal, math-wise, to put a variable in the boundary of integrals that's the same variable as what they're using in the function. So for that reason, you often see x's in your boundary and t's in your function, just so we're not utilizing the same variable more than once. So what you're being asked to do is you're being asked to find what happens at g of 1. So your 1 is actually being plugged in as your upper boundary. So what this is really saying is what's happening from -6 to 1 of this function. The picture is your function. So once you realize that, you're just turning it into a problem from what we did earlier in the chapter. So -6 to 1, so -6 is here, 1 is here. We have areas that are 15 and 11. They are both under the x-axis, so we add them up, make them negative, we get -26. So that is how we evaluate an equation where they're giving you something to plug in as a boundary. Show you one other thing that they do here to kind of throw you off a little bit. So this one, the lower boundary is thrown off. The lower boundary is 8. So it's 8 to x. You're putting a -1 in. So it's wanting you to get the integral from 8 to -1 of this function. Here's what they do, and they hope that you don't notice it because it's kind of, they feed on these like common mistakes. The boundaries are not in the right order. 8 should be the upper boundary, -1 should be the lower boundary because we want the lower number on the bottom. So when we get my answer, you are going to have to negate whatever you get, and that's such a common mistake. So -1 is here and 8 is here. So let's look between the curves there. We have a -9 and a -11 and a +6. So we have 6 on top, we have 20 on the bottom, so we get a -14. However, because my boundaries were flip-flopped, and that is something that you want to notice, this flipping of the boundaries, your answer would actually be negated. So the answer they are looking for is +14. I'll show you one more of those so you can kind of feel comfortable with this. So this is a g function that the integral is going from 6 to x. The boundary that you are replacing, you're going to replace with a -6. So you should notice that my boundaries are flip-flopped, which means my answer needs to be negated at the very end. So I'm going from -6 to +6. I have areas underneath of 10, 12, and 11. So that's 33 underneath. I only have an area above of 8. So when I put those together, I get -25. However, because of that boundary swap, because we notice my boundaries are not in the right order, I want to negate that answer. And so what the expectation is that you plug in 25. So I wanted to show you those. I have never had the ability to really get into that discussion before until I saw these questions on Delta Math, which just illustrate it really well in a pretty quick way.